All right. Welcome back, everyone. Ready for another deep dive?
Always.
Awesome. So today we are diving into the world of cutting tools.
Ooh, sounds exciting.
Oh, it is. So we got these excerpts from a product catalog, ISCAR cutting tools. And let me tell you, there's some pretty cool stuff in here. But what really caught my eye, and I know you're going to love this, is this new tool that's specifically designed for cutting titanium.
Titanium. Oh, man, you aren't kidding about cool stuff. That's a tough metal to work with.
It is.
Why is that? Why is titanium such a pain? I know it's great for aerospace and stuff, but what makes it so difficult to machine?
It all comes down to its strength, actually.
Oh, okay.
Titanium has this crazy high strength-to-weight ratio.
Yeah.
Like it's super strong, but also lightweight, which is why it's so popular for things like aerospace components, medical implants, all that stuff. But that same strength makes it a real beast to cut. Tools wear down super fast, the parts heat up like crazy, and you've got vibrations that can totally mess up the precision.
Yeah, I can imagine. I mean, just the heat alone would be a problem, right? Wow, so there are a lot of challenges there.
Yeah. So enter this new tool from ISCAR. They call it the ECK H4M CFR Endmill.
The ECK what now?
Right. I know, it sounds like something out of a spy movie. ECK H4M-CFR.
So, decode that for us. What does that all mean?
Well, that's what we're going to do. I was hoping you could help break down what each part of that name might actually tell us about the tool itself.
All right, challenge accepted. Let's see, the ECK could be like their product line or something, maybe. And then the H4, that might have something to do with the shape of the cutting edges. Probably just stands for metal,
Yep.
right?
Yeah, makes sense.
But the CFR at the end there, that's got to be the interesting part. I bet that's tied to their big claim. They're calling this thing chatter-free.
Okay, so chatter-free. Now, for those of us who, aren't machining experts, what's the big deal about chatter? Why is eliminating it so important in the machining process?
So imagine you're trying to write your name right, but you're on a roller coaster, your handwriting's going to be all over the place. Total mess. That's kind of what chatter does to a machining process. All those vibrations, they make the cut rough, uneven, wear out your tools way faster, and just make the whole process a real headache.
So a chatter-free tool, I mean, especially when you're working with something as demanding as titanium, that's a game changer.
Absolutely. And speaking of demanding, the catalog also says this tool can handle 2 times D full slotting. I'm going to need your translation on that one.
2 times D?
Yeah. What in the world does 2 times D even mean?
So picture this. D is the diameter of the tool, right?
Okay.
So 2 times D means this tool can cut a channel that's twice as deep as it is wide. Pretty impressive, right? I mean, that's a lot of cutting power packed into a small tool, which is a big deal when you're wrestling with something like titanium.
Wow, yeah. I'm starting to understand why they're so excited about this tool.
Oh, there's more.
Oh, there's more.
They're also really hyped about these new corner radii options they've introduced.
Corner radii. All right, enlighten me. Why is the corner radius something to get excited about? Okay, so think of the corner radius like the curve at the edge of a knife. If you have a super sharp corner, it's more likely to, snap or chip under pressure. Yeah. But if it's more rounded, it'll be way stronger and last longer. So the corner radius actually impacts the durability of the final product. And the fact that they're offering different radius options gives manufacturers more flexibility for different applications. It's like they're saying, hey, we got you covered no matter what you're making.
Smart. Okay, so let's try to put it all together. We've got this unique geometry, 4 flutes, those are the cutting edges, right? A variable pitch to reduce vibrations.
Yep.
And then they're using this grade IC900 material. I mean, is that the secret sauce here? What is it about these features that make this tool such a beast when it comes to titanium?
It really is how it all works together. So the geometry and the flute design, they help clear away the chips super fast so they don't build up and cause, you guessed it, chatter. Then you add in the variable pitch. That's like an extra layer of defense against vibrations. And that IC900 grade, that's probably some super tough heat-resistant material, something that can really withstand the punishment of cutting through titanium. It's like they engineered this thing from the ground up specifically to overcome all those challenges we were talking about earlier.
So, I mean, what's the big takeaway here? It sounds like we've got a tool that's not just capable of cutting titanium. It's like it's designed to dominate.
Exactly. Features for maximum performance, precision, all that good stuff. I mean, it seems like a real breakthrough for industries that relied on titanium.
Yeah.
And it kind of makes you wonder, like, what's next? As these tools keep getting better and better, is this going to change how we manufacture things on a larger scale? And could this kind of tech, I don't know, maybe trickle down to smaller workshops or even hobbyists one day? I mean, it's pretty exciting to think about.
It's definitely food for thought.
Yeah.
Well, on that note, we're going to wrap things up for today. Hope you all enjoyed this deep dive. As always, thanks for listening, and we'll catch you next time.
See ya.